The diagram shows a uniform lamina, A, B, C, D, E, F, G. The lamina consists of two rectangles forming an L shape, A, B, C, E, F, G, and an isosceles triangle CDE with DE equals DC. Dimensions in centimeters are shown in the diagram. Calculate the distance of the center of mass of the lamina from AG and from AB. The lamina is suspended freely from the point G and hangs in equilibrium. Find the angle AG makes with the vertical. Okay, so here's the shape. So we'll let M, because it's uniform lamina, let M be the mass per unit area. And then we're going to say that the center of mass, which we'll suppose is, say, here, say, we'll take that to be G, curly G, and this will be X bar, Y bar. Then total mass capital M is equal to, so M per unit area then, so we've got 2 by 12 is 24, plus, so that was this area here. Then we've got, this will be 6 by 2, won't it, which is 12, M, plus, so that's that rectangle, and then half base, which is half of 6 is 3, times the height, which is 6, M. So that's 18, isn't it? 6 is a 36 over 2 is 18, and this will be 12, that's 30, 54. So that's the total mass then of the composite shape. So calculate the distance of the center of mass. So taking moments about AG then, let's do that. So I'll do it up here, so A. Let's take moments about AG. Gives. Okay, so this shape here, the center of mass for this one will be this distance, won't it? This is of 24m times this distance here, which is 1. So 24 mg, because that's the weight, mg, times 1. 24 mg times 1 then, plus, this shape here is the center of mass for this. So this would be halfway along, the 6 would be 3. So this distance is 3. But this distance is 2, so 2 and 3 is 5. And the weight of this section is 12m, so it's 12m times the distance 5, plus, then it's going to be 18m, isn't it, for the triangle? And its center of gravity for the triangle will be on this line of symmetry here. And that again is a distance of totaling 5 from the edge, from the line AG. GA rather, so that would be 5. So that's equal to then, the center of mass is x bar, its total mass is 54m. So that tells us then 54 mg rather. So the mg's will cancel all the way through. We've got 24 plus 60 plus 90. So 24 plus 60 plus 90 is equal to 54 x bar. So what I'll do is I'll write that down on the line below. So 24, cancel the mg's all the way through the equation, 24 plus 60, 5 12s are 60, plus 90, 5 18s are 90, is equal to 54 x bar. 24, 60 and 90 is 150, 174 is equal to 54 x bar. So that tells us then that x bar is equal to 174 over 54. Let's just tap that in the calculator then. I'll put it over here. 174 divided by 54. 29 over 9. Okay, so that's that distance there then. X bar is 29 over 9, which is 3 and 2 ninths, if we want to write it as a proper fraction. Okay, so 3 and 2 ninths distance from AG. Now B, part 2, that was part 1. Now part 2, let's do the same again. Let's take moments this time about AB. See what we get here. Oops. So we're taking moments about AB. So what have we got here then? Let's have a little look. So again, I use this as my rough area because it's right by the diagram. This was working and it should be included, but I'm just going to use this little area to write down our working. So taking moments about AB now. So I'll put it in here afresh. Take moments about AB. So what have we got? We've got 24m times this height here, which is 6. And then we've got this shape, which is, this area is 12m times 12m times this height, which is 1, plus, and then we've got 18m for the triangle, times the height of the centre of gravity here. It's a third away up from the base, which is 2 units. This is also 2 units, so it's 4. And that's equal to 54m, the total weight, times y bar. So we got 24 times 6, 6 20s, 120, 144. So it's 144 plus 12. 4 18s are 72. Tap it in the calculator if you need to. Is equal to, and I've cancelled by the mg's all the way through. That was an mg there. This is an mg, mg and mg. So cancel the empties all the way through the equation. It's 54 y bar. So let's just take that down then. So we got, so 144 plus 12 plus 72 is equal to 54 y bar. And that tells us what y bar is. Okay, 72, 84, 144, 148, 228, 228 over 54. So 144, 156, 158, 228. So we've added that up correctly. Over 54. 228 over 54. 38 over 9. And then 4.4 and 2 ninths. There we go. So that's the y bar. So now it says part B, laminar is suspended from G here. So we got the distance from here and the distance from there, and we know the total distance. And then it says find the angle AG makes with the vertical. So the vertical line now, if you imagine this is a string, we're going to reorientate the shape, because that's actually, when you hold it with a string, that's where the vertical line is. Now the centre of gravity, so there's our vertical line. We want to find out this angle here. AG makes with the vertical. This is AG. We need to find out that angle here. Let's call it alpha. So this distance here in the triangle then, that distance is x bar, isn't it? Which we said was 29 over 9. So that's 29 over 9. This y bar, the height, is this height here. So y bar here then, which we got from below, 4 nines are 36, so it's 38 over 9, isn't it? 4 nines are 36. 38 over 9, or 4 and 2 ninths. So this height here, which is what we want, is we have to, take 12 away from 4, which we get 7 and 7 ninths. 12 take away 4 and 2 ninths is 7 and 7 ninths. So the tan of alpha then, the angle alpha is the angle that makes for the vertical. The tan will be the opposite over the adjacent of this triangle. So it's 29 over 9. So B, tan alpha is 29 over 9 over the adjacent, which is 7 and 7 ninths. 63 and 7 is 70 over 9. 70 over 9. The 9s will cancel. We simply get 29 over 70. So that tells us what alpha is then, doesn't it? Alpha is equal to shift tan of 29 over 70. So let's tap it in the calculator. We're in degrees mode. Shift tan of 29 divided by 70. 22.50 degrees. And that's to 1 decimal place, 22.5 degrees.